Hello everybody, my name is Sam Gilk and I'm a software applications engineer at Bosch Rexroth. Today I'm going to be explaining a few different communication methods in a Node-RED app running on your ctrlX core. I'll be covering OPC UA, MQTT, HTTP over REST API, the ctrlX core data layer, and also be providing a real-world application at the end to kind of tie it all together. I'll be doing all of this in a ctrlX core virtual emulated device, but all of the same processes can be followed on a physical core. I'll be assuming that you have all of the necessary apps installed and licensed properly already. We have some videos that cover these topics, which I'll link in the description, as well as all the apps used in this demonstration. So let's get started with the data layer. So in this demonstration, I will be reading and writing from the data layer on the local device, so the local virtual control that I'm running the Node-RED app on. However, this same process works for reading and writing for another ctrlX core on the same network. So I have a PLC app running on this core that has a few exposed variables, an integer, a string, and a Boolean value. To begin, I'm going to drag and drop on this data layer subscribe node, which comes as part of the ctrlX automation package. If this is not installed by default, you can install using the manage palette interface here, and then searching for Node-RED contrib ctrlX automation. Now that we have our subscription node here, we'll go ahead and configure it. The first thing we'll need to do is actually network the device. So we'll need to add a new ctrlX config subscription. And to do that, we'll need to first add the device configuration. So we'll dive into these two menus. Here, you'll specify the device address. If you're pulling from the local device data layer, localhost will work here. I'll use my exposed device address. Next, you'll need to specify credentials. So I've actually created a user specifically for Node-RED here, and you'll need to make sure that this user has permission to read and write to the data layer. And I've just given this user full permission. So we'll go ahead and enter those. And then you can name your device. So we'll call this local core. Now you can add a name just for this subscription. So we'll just call this local core sub. And then you can select your publishing interval. So that's the minimum time in milliseconds that a new piece of data will be pulled on this node here. So we'll just use the default value. And now at this point, if you have your network set up correctly, you should be able to browse the data layer. So we'll subscribe here to the PLC integer like we discussed. Symbol. Okay. And then we'll give this node a name. So we'll call it PL sub PLC int. Okay, so now this should be configured correctly, and we should be able to add a little display. For example, a gauge, and show this on our Node-RED dashboard. So this integer ranges from 0 to 1,000, so I'll just set that up correctly, and then this will just be PL gauge int. And now, if we go to our dashboard, you should be able to see this value incrementing directly from the PLC. Next, we'll look at the data layer request nodes. All right, so now that we have our data layer request node here, I'm going to briefly explain what's going on behind the scenes in the PLC app. So all we're going to do here is simply write to this value PLC bool which is available on the data layer. And all that's doing is switching the value of the string between on and off, which will also read back on our Node-RED app. So to do this, I'm going to add a button in the Node-RED app. And then one thing to look out for is that Node-RED and the data layer do not operate using the same data types. So I'm going to explicitly specify the type of the variable here in our message payload. So this is going to be of type bool8 when using a Boolean value on the data layer. And we're just going to write true. Now this will be sent through this function block every time the button is pressed, so we don't need to worry about configuring the button, but we do need to set up our data layer request node. So we're going to be using a write method. And then at this point, we should be able to browse down to the path again because we've already configured our device in the data layer subscribe node, and we've selected it here as local core. So we'll browse down to the PLC bool and select that. And there's our path. Now we want to make sure that, again, we're specifying the type in the message payload when we send it on the data layer request. So we're going to select that, and then we're going to say pl-write PLC bool as the name of the node. And there we go. Now, one last thing, I need to make sure the button's on the right tab here because I have multiple for future purposes in this demonstration. So I've added the button to our data layer tab on the Node-RED dashboard, and then I'll redeploy this. And now, when we look back at our PLC app, we can see PLC bool is false. When I click the button, it is now true, and it shall reset itself after 20 counts here. So there we go. We wrote down to the data layer. Next, we'll go ahead and add a final subscription to view the value of the string. Okay, so the last piece here will be to add a second data layer subscription node, and then we are going to view this value of the string on our dashboard. So I'm just going to use a text display here. We'll drag that in, and then we'll use the same subscription as we've already set up previously, but we're going to change the path here to PLC string. Okay, so now we have PL-sub PLC string. Okay, and then we just want to make sure that our text display is on our data layer tab. This is just going to be PL text PLC string as a name. Them close to each other. And then I just want to make sure that the position of the string is above the button. Okay, so now when I deploy, we can go back to our dashboard. When we click the button, we'd expect this text value to change to on. And there you see it. Now it should go back to off in a few seconds. Perfect. All right, so everything is working as expected for the data layer. Next, we'll take a look at OPC UA communication. All right, so now we're going to go ahead and try and recreate a similar dashboard using OPC UA as the communication method. So we'll use the same PLC app with the three variables PLC int, PLC bool, and PLC string. Before we get started, you're going to want to make sure that you have the following package installed on Node-RED, which is Node-RED contrib OPC UA. That's what I'll be using in this demonstration here. So the first thing we're going to need is an inject node. So in this method of OPC UA, we're going to actually have to pull the OPC UA server, which is different than some other publisher subscribe methods that we'll be talking about in this video. So we're going to have to specify here the time interval at which we want to retrieve data from the OPC UA server. So we'll say, just for now, every 1 second is fine. Next, we're going to want to specify the topic that we're going to subscribe to. This is an advantage of using the data layer nodes, is you can actually browse down to this, but for the purpose of this video, I've just copied the path to the PLC int variable. Also, you'll need to specify the namespace of the variable on your data tree here. And this needs to be populated in the message.topic property. Okay, so now that we have this inject node, we'll go ahead and add a OPC UA read. So this is going to be a client, and the action will be read. So we need to configure our endpoint here. So I already have a few set up, but I'll go ahead and create a new one. So by default, OPC UA on the ctrlX core is done over port 4840. So the address will be as follows: opc.tcp, and then the address of your core. So if the server's running locally on the same core as your Node-RED app, you can use localhost, but I'll just use this. And then you'll need to configure your security policy. So whatever is accepted on your OPC UA server, and then you'll need to specify credentials as well. So mine is looking for a basic 256 SHA-256, and then sign and encrypt. And finally, I'll add my credentials that are configured on my OPC UA server. So now we'll call this OPC UA read PLC int. If you want to use certificates or anything else, you can configure that here as well. I will not be using them. So we'll go ahead and call this read, and then from here, we'll want to display this somehow. So I'll add a gauge, similarly to the data layer demo. We'll put this on our OPC UA page, and we'll call this data layer OPC UA read PLC int, or whatever you want to call it. Again, goes from 0 to 1000 here. Okay, so now when we deploy, you're going to see an error at first, because you're going to need to accept the certificate on your OPC UA server. So if you go here to your certificates and keys, if you're running your OPC UA server off your core, that is, you'll need to do this. If you go to certificates and keys and then OPC UA server, you should see a rejected certificate here. You'll actually need to trust this on the server side. So I'm going to go ahead and trust, and now you'll see that the session is active and we have active reading here. All right, so now that we've established a connection to our OPC UA server using the PLC integer endpoint here, I'm going to go ahead and copy this so that we can read a separate endpoint, which will be PLC string. So our client node is going to be configured the exact same. I'm just going to rename it for clarity's sake. And our inject node, our endpoint, is going to change from PLC int to PLC string. Okay. And then finally here, I'm just going to use a text display rather than a gauge to view the value of our PLC string. So I'll label it PLC string, make sure it's in the right group here for our dashboard, and this will be OPC UA read PLC string. Okay. So now when I deploy this, we should be able to see both the PLC integer and the string value on our dashboard. So we'll see session active and active reading on the node readout here. So when we go to our dashboard, we now see our PLC integer incrementing and our string value, which is set to off. Next, I'm going to add a write method over OPC UA to switch our PLC Boolean value, which controls the string. So I'm going to use a button on the dashboard to initiate this write. So I'm going to add a button, make sure it's in the right group, and I'll call this OPC UA write init. And now I'm going to copy another OPC UA client, but this time we need to make sure that we set the action property to write rather than read. The endpoint configuration will be the exact same. So OPC UA write, and this will be PLC bool. Now the last step here is to set up the data that we're sending to the OPC UA server. So I'm going to configure that in a function node here. The format that the OPC UA client node is expecting is that the payload, message.payload, is the actual value that you're writing. And then our message.topic will contain a string of the endpoint. So I'm going to grab that endpoint from a separate OPC UA client that I have running here, connected to our OPC UA server. This is called UA Expert, is what I'm using. So I'm just going to copy the path here to our PLC Boolean and paste that. The only reason I'm copying from here is if you copy from the inject node, you do get some spaces like this, and you just have to take them out. And then the last piece here that we need to include is our data type. Now, I know that I mentioned in the previous section on the data layer subscription nodes that the data layer operates using different data types than Node-RED, and that's still true. In this case, though, we need to use the data types that are specified on the OPC UA server, which in this case is Boolean rather than bool 8 directly to the data layer. So I'm going to specify Boolean. And now, when I deploy this, we should see a button on our dashboard, which when we click it, will switch the value of our PLC string by switching the Boolean value to true in the PLC. So here's our button. When I press this, we would expect our PLC string to switch to on for a few seconds. There we go, we see on and off again. Do it one more time. And then I'll show as well, you can confirm this on a separate client. So we can see here, the value is currently false. If I write and refresh, now see the value is true. So there we go. We've now created a read and write method in Node-RED to an OPC UA server. You also can see value written is displayed underneath the client node. So that concludes our section on OPC UA in Node-RED. Next, I'll be covering MQTT. In this section, I'm going to be explaining how to publish to an MQTT broker over Node-RED. So the MQTT broker I'm going to be using is called Mosquito. You can install this as an app on the ctrlX core, but this method of publishing and subscribing over Node-RED will work with any broker. So very quickly, I'll show you how to set up a client in the Mosquito broker. So if I click here, Management Center from the ctrlX core web interface, I'll need to come, this is the main dashboard of the Mosquito broker. Now if I come to the left side here, I'll click on this Clients tab and then click New Client. So I'm going to set up a very basic Bosch Rexroth client. Save it. Now I'll need to assign client roles. So in this case, I'm just going to make this user a client, which should give me read and write permissions through our Node-RED app. So now that that's all set up, I'll come back to our Node-RED coding interface here. And in order to publish to the broker, I'm going to use what's called this MQTT out node here. Now the first step will be setting up a broker configuration. So I'm going to call mine local broker because it is running locally. Now the Mosquito broker runs on port 8883. So you'll want to set this port to whatever port your broker is running on. And then I'll use the IP address of my core. Okay. And then I'll need in the security section to specify the credentials of the client that I set up on the broker. And you'll also need to set that here on your client ID. Mosquito broker will also expect that you're using TLS, so I'm going to set that up. The configuration doesn't need any certificates or keys here, but you do need to specify a server name. So I'm just going to call this local broker. And you don't need to verify the certificate. Okay, so I'm going to just call this local TLS. All right, so now this is a complete broker configuration. We have our server, our port, we're using TLS, and we've specified that we want to use MQTT v3.11 as our protocol and given a client ID, as well as credentials for our client. Okay. Now, this is where we want to create a topic that we're going to publish to the broker. So in this demonstration, I'm going to just write a random integer to the broker. So I'm just going to call this random_int. And now QoS stands for quality of service. So if you want to guarantee that you're only sending and receiving one message, exactly one message to the broker, you'd use QoS2. QoS1 will send at least one message, so it could potentially be more. And then 0 is kind of a fire and forget. So you'll attempt to publish one time, but you're not handshaking at all with the broker. So I'll use QoS2, and I'll set this retain to true, which means the last value sent to the broker is stored in the broker, even if you quit sending values. So then I'll name this MQTT publish, and then this will just be random int. Okay. Now, in order to generate this random int, I'm going to create an inject node here, which is just going to send really any value at some interval. I'll just do 0.5 seconds. And then where I'm going to generate the random integer is in a function node. Okay. So I'll link these, and then I'll just say message.payload equals math.floor, math.random, and this will be times, we'll do 0 and 1,000 plus 1. That'll give us a number between 1 and 1,000. Okay. So now that we have this, once I deploy, if everything is set up properly, we can see here that we're connected. And now if we go back to our broker, eventually I'm going to subscribe to this node and we'll view it on the dashboard. But for now, we can test that our topic is being published right here. In our topic tree, we can see, yep, random int is coming in and it's changing every half a second to some random value between 1 and 1,000. So the last step of this MQTT section will be to subscribe to our random integer topic on our Mosquito broker and display this on our Node-RED dashboard. In order to do this, I'll be using an MQTT in node here. We've already set up our server, which we use to publish the topic as well. So I'm going to call that local broker, just set that here. Our action will be to subscribe to a single topic, and our topic is random int. Again, we'll use quality of service level 2, and then we want to output this as a string. And the name will be MQTT subscribe random int. Okay. And finally, I will use a gauge to display this value. And it will be between 0 and 1,000. We'll just call this random integer. And I'll make sure this is in the correct group. And this will be, oh, it's not OPC UA, sorry, MQTT. And we'll call this MQTT random int gauge. Okay. So now when we deploy, we should see connected display beneath our subscription node. And then when we go to our dashboard, we can see a random integer, which corresponds to the value on our Mosquito broker. All right, so that concludes the section on MQTT. The last communication method I'll be covering in this video is going to be HTTP requests. Specifically, we'll be making requests to the ctrlX data layer REST API. The first step in this process is to obtain an authentication token from the ctrlX authentication server. So I'll do this using a HTTP request node here. And I like to configure the request message in a function node. I think it's a little more visible than the node itself and gives you more flexibility. And then I'll initiate this request using a button on the dashboard. So I'll make sure it's in the correct group here, and then I'll just call this HTTP auth init. And then, like I said, I'll be configuring the message in this function node here. So the only items we need to set here are the method will be set by message.method. You could just say, yep, it's going to be a post request, but each their own. And then I'd like to return the data as a parsed JSON object. All right. So in this function node, the first step will be to say we want the method to be a post request. All right. Next, I'll configure the URL that we'll be sending this post request to. So I've already gone ahead and loaded some comments into this Node-RED app that just have the formatting of the authentication server endpoint. So I'm going to paste that in here, and then I'll just need to put in my ctrlX core hostname. And it's operating on port 8443 for the REST API. All right. Next, I'll need to put in my credentials to obtain this token. So this will be passed as a JSON object with the following properties. You'll have your name, which is some authorized user on your ctrlX core. And then password. Okay. Now we have that, and then we'll also need to specify the content type in a header. So I'm going to create an empty object here, and then pass in property called content type, and set it equal to application JSON. All right, now that should be everything that we need to send a post request for an authentication token. I'm going to go ahead and log this entire message to the debug window just so we can view it if anything goes wrong. And then I'm going to also log the output of the request, so the response, to the debug window as well. So now when I deploy this, we should have a button on the Node-RED dashboard, and when I click it, an HTTP request should be sent to the authentication server, and we would expect to receive a authentication token. All right, so here was our message object. You can see we sent a post request to this endpoint with these credentials. And in response, we received an access token. All right, so now that we've obtained our access token, we can use it in a GET request to the ctrlX data layer REST API endpoint that's hosting our PLC integer. So let's go ahead and set that up. So first, I'm just going to copy these couple of nodes here. I'm just going to rename this HTTP request node. It's now going to be a GET request to our PLC int. And again, we're going to set the message method using the message.method property that's passed into this node. And we'd like to return the data as a parsed JSON object. Okay. So the next step here, I'd like to store our access token just for easier use in the Node-RED application. So we shouldn't need this debug node anymore. We already know we're getting the access token. And what I want to do is store a global variable called access token in Node-RED. And I'm just going to set it to the value of our message payload property access token. All right. So the next time we run this post request, when we retrieve the access token, it should be set to global.accessToken in Node-RED. Next, I'm going to set up the GET request message. So the method is no longer post, it's going to be GET. And I've already written out the endpoint here, endpoint URL, just to make it easier for this demonstration. And all that is following this scheme right here to a data layer endpoint. So I'll paste that in. We should no longer need the credentials because we already have an access token. But what we do need to do is add a new header property called authorization. And in this property, we're going to set it equal to bearer with a space after it. Remember that? And then we're going to get our access token variable that we set above. All right, and then I'm just going to log this to the debug window just so we can make sure that our access token is coming in correctly. And then finally, I'll output the entire response to the debug window. And in order to initiate this GET request, I'm just going to use an inject node here, which I'll trigger manually in the Node-RED app. So once I deploy this, I'll go back to the dashboard and get another access token. Now at this point, our global.access token should have been set to that value of the access token. And now when I inject here, this is our message sent in the GET request. So we can see our payload is empty. We no longer have credentials, but our header now includes this authorization field, which has pulled in our access token. And again, our content type is application JSON. Now, this next message here is the response from the REST API. So if we look at our payload, we can see, yep, we got a value of 451 and a type of integer 16. In this final section, I'll be giving a brief demonstration of the type of tools that can be built using template nodes in Node-RED, where you can write custom JavaScript, HTML, and CSS code in order to interact directly with the document object model of your dashboard web page and create interactive features. So in this application, I have a subscription to an MQTT broker feeding in some input JSON formatted data. And the goal of this tool is to be able to create a custom output structure with references to that input data. So here's what a template node might look like. So you can just write custom JavaScript. And if I go to the dashboard, this is what it's produced. So you can make very complex features on your web page. So here we have a table which is used to build the output structure. Here's the input data, which came through MQTT. And so, for example, if I want to create some output reference 1, and I'll reference this hardware field that's coming in on the input. Now, if I add this to my output schema and parse, you can see we've pulled in this value. Now, if this input data changed, it would still be passed through the schema and you would receive a new value here. So you can build out very complicated data structures that are nested. So if I select an object type here, then I can create nested references, etc. Thanks everybody for watching. This concludes the tutorial on communication in Node-RED. If you have any questions, please feel free to comment or post to the forums that I link below. I'll be providing some useful links and general notes in the video description. Finally, I encourage everyone to subscribe to the channel for future tutorials and to get involved with the ctrlX developer community. Thanks.